You dropped your phone this morning, maybe from your nightstand, maybe pulling it from your pocket. The screen's fine. Not a scratch. You didn't even think about it. In 2007, Steve Jobs had a prototype iPhone in his pocket for 2 weeks. The plastic screen looked like someone took sandpaper to it. Keys scratched it, coins scratched it. The fabric of his jeans scratched it. He called Corning. He needed glass that could survive your life. Real life. Pockets full of keys, tables, concrete. The problem? Glass that thin shouldn't be that strong. Physics says you can't have both. This is how they broke the rules. Before iPhone, phone screens were plastic. Made sense, right? Drop plastic, it bounces. Glass shatters. But plastic scratches? If you look at it wrong, Jobs wanted something different. He wanted you to touch the screen with your finger. Drag your thumb across it. Do that 1,000 times a day for years. Regular glass couldn't handle it. Too thin, and it breaks from its own weight. Below 2 millimeters thick, the internal stress tears it apart. Glass is silicon dioxide, rigid molecular bonds locked in place. That rigidity gives you strength, but also brittleness. There's no warning, no flex. The bonds just snap. Catastrophic failure. Corning had 6 months to solve a problem that normally takes 3 years. They dusted off a failed experiment from 1962. Something they'd made for car windshields that nobody wanted. Too expensive, too complicated, but it was their only shot. Here's what they do. Take a sheet of glass, drop it into molten potassium salt, heated to exactly 400 degrees Celsius. Leave it there for 8 hours. While it sits in that bath, something wild happens at the molecular level. Normal glass has sodium ions. Small ions, about 2 angstroms across potassium ions, are bigger. 2.7 angstroms, 30% larger. At 400 degrees, those bigger potassium ions migrate into the glass surface. They physically shove the sodium ions out. You're cramming bigger atoms into spaces designed for smaller ones. The surface gets compressed, massively compressed. Think about trying to tear a rope while someone pulls it tight. The tighter they pull, the harder you have to work to break it. That's what's happening in your screen. Regular window glass breaks at 100 megapascals. Gorilla Glass survives 900 megapascals, 9 times stronger, all from swapping invisible ions. The compressed layer is 40 micrometers deep, half a human hair's width. That microscopic layer is what saves your screen. Corning makes this stuff in Kentucky and across Asia. The Kentucky facility runs non-stop. 400,000 square feet of production floor. Each sheet sits in molten salt for 8 to 16 hours. Temperature has to stay within 2 degrees of 400 Celsius. 2 degrees. If it gets too hot, the glass warps. Too cold, the ion exchange stops working. They've got sensors checking temperature 100 times every second. One mistake ruins thousands of sheets. They ship over 1 billion units every year. Samsung uses it, Apple uses it, Google, Xiaomi, Oppo. Everyone uses it because nothing else works as well. This wasn't just about making better phone screens. This made touchscreen computers possible. Without this, we'd still be using styluses. That 40 micrometer compression layer does everything. When you drop your phone, impact creates tension waves through the glass. Tension wants to pull molecules apart. The compressed surface pushes back with 900 megapascals of force. Most drops never generate enough energy to overcome that. But here's the clever part. The compression fades as you go deeper. At 40 micrometers, you're back to regular glass. The center is normal, flexible glass. If they compressed the whole sheet, it would be too brittle. The internal stress would make it fail randomly. So they engineered exactly how deep to compress. Too shallow and you don't get protection, too deep and you get brittleness. 40 micrometers is the sweet spot. Each new generation pushes that boundary. The latest version, Gorilla Glass Victus, survives drops from 2 meters. That's twice what the original could handle. $8 billion devices have Gorilla Glass right now. You've got it in your pocket, your tablet, your laptop, maybe your watch. Here's what that means for you. The screen is the most expensive part to replace on any phone. Drop an iPhone and crack the screen. You're paying $279 minimum. Maybe $329. With Gorilla Glass, most drops do nothing. Zero damage. Think about how much money that saved everyone. Billions in repair costs that never happened. Insurance companies price their policies around how often these screens actually break. Which isn't often. You're not just watching a video about chemistry. You're learning why you can pull your phone out 100 times a day without worrying. Why your kid can hold it without you panicking. Why dropping it doesn't mean automatic repair bills. Gorilla Glass turned phones from fragile gadgets into tools you actually use without thinking. Jobs didn't invent any of this. Corning figured out chemically strengthened glass in 1962. They made it for cars. Nobody bought it. What Jobs understood was simpler. The interface matters more than anything else. A screen that scratches becomes useless. A screen that shatters is dangerous. Gorilla Glass proves innovation isn't always about inventing something new. Sometimes it's recognizing which old solution fits tomorrow's problem. That ion exchange process is 60 years old. What changed wasn't the chemistry. What changed was understanding what problem it could solve. Without it, smartphones probably would have stayed expensive toys for careful people. With it, everyone has one. Next time you drop your phone and pick it up unscratched, think about those potassium ions. 8 hours in molten salt at 400 degrees. 40 micrometers of compression stopping every crack before it starts. Tomorrow, we're looking at OLED displays and how they bend without breaking the screen tech that Gorilla Glass makes possible.